In this episode of The Bear Roars, Dan Caruso sits down with Mike Conover, founder and CEO of Brightwave, to explore how AI is transforming the way investors understand risk, complexity, and opportunity. Mike shares his path from studying network science and complexity to building an AI platform that helps investment teams dissect massive data rooms, surface hidden risks, and pressure test theses at scale. He explains why the launch of ChatGPT stunned even insiders, how autonomous AI agents are changing research workflows, and what it takes to build an AI company in the earliest innings of the industry. The conversation goes beyond the mechanics of large language models to tackle bigger questions. What problems will AI actually solve? Where does human judgment still matter most? And how do we ensure innovation strengthens communities rather than erodes them? Let's poke the bear to kick off the conversation.
Mike, I'm looking forward to this because we know each other, but we don't know each other well. So I feel like this is one of those podcasts where I'm going to get to know the guests through the podcast itself. So,
Yeah, and I hope similarly.
Great. And we're going to talk a lot about AI, the application of AI.
Yep.
But where I want to start with you is your education, because
Okay.
the degree fascinates me.
Sure.
So I want to go a little bit deep into kind of your degree, and it's Indiana, right? So
That's
Indiana
right.
of
Yeah.
now new football fame.
Go Hoosiers.
Go Hoosiers. That's pretty crazy. I'm not a big
It
college.
is crazy. They were not much to speak of when I was there.
Oh, well, there's not much to speak of, period, until
Yeah.
this year. I mean, this is a Cinderella story.
Yeah.
I'm not a big college football. I'm a big pro football guy, but not
Yeah,
a big college
nice,
football guy.
nice.
But I heard people talk about this story. But let's talk about your experience there and
Sure.
what your degree was all about and why. I mean, it's a pretty deep topic, and
Yeah.
I love math and I love complexity, so it's fascinating to me.
Sure. Yeah, definitely. So IU, I think there's some spiritual similarities to Boulder in some ways, particularly with respect to this group at IU, where you have kind of a center of excellence at Indiana University around complexity and network science. And we've got a little time here, and so I'll share. My dad worked at the university, and I flew out one Christmas break to meet some of the faculty. And
He worked at Indiana?
correct, yeah.
Okay,
It was an
you kind of referenced that direction, which is CU. So
yeah, it was, yeah. I guess it's probably that way actually, east of us here. But small town that attracts really exceptional people. I mean, we've got Nobel laureates, and in this complexity group, some of the most preeminent thinkers on complexity science and sort of how information or diseases spread through social networks. And my work, and one of the things that attracted me to complexity science is, and you think about quantum too, right? There's this idea that beneath the surface of our day-to-day lives are hidden structures that govern the true course of events, but that are difficult for us to touch or see or feel or apprehend, but that have structure and reality all the same. And I know you're a music fan, and so when you're standing in the balcony at a venue and you see waves rippling through a crowd of people, or like something happens at an exit and there's kind of this compression wave that emanates from an event, you can start to see how like a crowd of people can behave like a fluid. And so it turns out that a lot of the tools of statistical physics can be applied to systems that have nothing to do with gas molecules, say, and we can generate insights into how the world actually functions.
I've been listening to some podcasts. There's a podcast called Mindscape, and in one of the pods on Mindscape, they were talking about how does information, is that a form of a living thing? The way information exists, permeates. Is there something more to it than we think of? And they were talking about an experiment, which I'm going to not be able to replay very
Sure.
well, but maybe it'll trigger with you, where they used a butterfly, and it was passing information into the caterpillar that would make sense in the butterflies, perception of the world, but not the caterpillars, to see if the information would live even as
Yeah,
the caterpillar.
through the metamorphosis
Yeah,
process.
and it did.
Yeah.
It kind of maintained
Yep.
some kind of recognition of, I don't know if it was color or sound.
Yeah.
And there's really no easy way to explain
Yeah,
how
because
that could have
the
been.
interior of the chrysalis basically liquefies.
Yes.
And so there's this question of like, where is that memory stored?
Mm-hmm.
And we were talking before we started about sort of error correction, and that parallel between quantum error correction and this question of like, as DNA is replicated during cellular division, how do you ensure that, because DNA is basically an information storage mechanism, and sort of this idea of like entropy is the quantity that is used in mathematics, as I suspect you may know, to measure the amount of information.
Entropy is my favorite law of physics, and
and
entropy is just, I don't know why that's always been fascinating to me to think about it, not just in terms of it being considered a law, second law of thermodynamics, but also kind of what it means relative to, maybe a broader meaning relative to how information, what information means and doesn't mean, how evolution really happens or doesn't happen.
Well, and like why, for example, like the life itself is like this highly structured process, and this kind of self-replicating propagation of a structure through time, which is sort of the opposite of what happens globally in the universe, which is that things get colder and more disordered.
Destruction.
And so, there's
life overcomes entropy and it takes an enormous amount of energy and resource to produce the complexity of life. While entropy is constantly fighting against you, yet complexity, including life, has happened anyway. So how do you resolve that? I don't think we know as humankind yet.
So one of the ways that and obviously I don't have any answers on this, but one of the things that drew me to the field of study is sort of, you reflect on this idea of like, when I eat a peach, when does it stop being a peach and start being me? Or the Edvard Munch quote, I think he had it on his tombstone, "From my rotting body, flowers will grow and I am in them, and that is eternity." And this idea that the world is a process flowing through itself. And in complexity science, there's this idea of a dissipative system. And, we've got some sunlight on us here where the world is being bathed in an energy source. And much in the way that you can hike up Boulder Canyon and look at a whirlpool in the creek and say, look at that whirlpool. And though the molecules that are flowing through it are always different, you can still talk about the thing itself that is constantly being sort of turned over. And I think about organisms as kind of whirlpools in time and space, where energy and matter are flowing through a structure that is sort of has some self-catalyzing properties. And I do think that there are information theoretic, sort of consequences of that property of the world. And so, as a younger person, you sort of reflect on all of this and you kind of want something to do about it beyond just like, wow, like apartments are kind of like honeycombs, man. Like it's like big beehives for people, which is sort of like a moot. It's interesting to remark upon, but it's not that useful. And so at IU, there's this group, the Center for Complex Networks, and that focuses on applications of these sort of mathematical techniques for understanding complex systems to, the spread of diseases on the airline network, for example. And so it was a center of excellence for pandemics research during originally H1N1, but then, COVID as well. And looking at how you can think of, imagine you have a sequence of chambers connected by tubes that are filled with water, and you drop a dye into that environment. You can sort of see that dye diffuse through that network of, you can think of that similar to like the airline network, and see, if you have a disease propagation event at Chicago O'Hare, how quickly will it reach Dallas-Fort Worth? And then you have the airline network and the local commuter network. So you have these two different networks sort of evolve at different time scales, and you can predict quite accurately where disease will spread using techniques like this. And there are parallels then to how information spreads through social networks. And it's like a different type of contagion. Typically, you have to be exposed to an idea multiple times before you internalize it. But whereas like you get the flu and you're exposed once and now you have the flu. But you can use these models of these sort of statistical models to make fairly comprehensive and robust predictions about how the world will unfold in these contexts as different as how information spreads through on Twitter and how diseases spread through the airline network. And so our work focused on the large-scale structure of propaganda campaigns and political polarization using the data set from GNIP, back in 2009.
And GNIP's a Boulder-based
startup.
Was
that,
a Boulder-based
yeah,
startup.
Distributed the Twitter fire hose, and we got very, very early access to that. And, we're among the first to notice that there may be something to say about the intersection of social media and politics.
Oh, really?
Yeah.
Oh, well, we'll come back to that maybe a little bit. There was a book that came out. It was like this thick. I don't know, maybe it was more than 20 years ago now. And the scientist and mathematician who put out the book named it A New Type of Science.
Yeah,
all
Stephen
about
Wolfram.
complexity.
Yeah.
Whatever came of that, I mean, it was a big, when he came out with that,
Yeah.
he made the big declaration, I'm discovering a new branch of science, and I don't think that ever was viewed that way.
Yeah. I mean, so that's an interesting, I have not read that book. It's a very thick book, as you sort of.
A lot of pictures of complexity.
Yeah, and
examples.
genetic algorithms
Yeah.
and cellular automata in particular. I think the impact has been. I mean, he's the creator of the Mathematica software. So like he's definitely an impactful person. I don't know that wound up being. Extraordinary claims require extraordinary evidence. I don't think we yet have the receipts. But this sort of question of like how can we try to understand the sort of levers in complex systems. You think about like economic development in Colorado, right? And it's this marketing problem on top of an economic problem on top of a skills problem, and it's like, well, where are the fulcrums that we can use to continue to drive job growth in Colorado? And it would be very nice if there was like a mechanism to say this is the one.
We're going to get a tech crowd here, about 25 people in this room actually.
Yeah.
And we're going to make it a kind of an hour and a half discussion, not a fundraiser campaigns, running for governor. A good likelihood he'll be the next governor.
Okay.
But the whole topic is going to be around something that is common sense to people like you and me, which is the more vibrant your tech ecosystem is, the more vibrant your overall community will be. You'll have more economic activity that benefits everyone, more tax dollars. All the things are pretty obvious. Yet we're doing a lot of things on the political side in Colorado that seem to be taken for granted, that we're a good ecosystem for that, and maybe beginning to scare some innovators away. And we need to get our political leaders maybe being a little bit more self-aware of what their what impact they may be having.
Elections have consequences.
Yeah, exactly. So if you're around this Friday and are able to join, it's a really interesting crowd we have assembled for that.
Well, I've appreciated your activism. Your sort of notifications about the city council election. Inspired me to like, okay, I got to make sure that I get out there. And I think like, it's like absolutely the case that the policy decisions you make, like humans are really bad at understanding those sort of long range correlations where it's like maybe 5 years from now, these effects are going to be, be experienced. But particularly in a place like Colorado where you've got to kind of fight for every inch and every win, where it's not just this, we don't have all of the inertia of the Bay Area, for example, where it's just, that's the default assumption where somebody wants to move if they're young and want to go into tech. I think, just making sure that we have a policy ecosystem that supports entrepreneurship and a thriving tech ecosystem, you got to be really, really actively involved.
Yep. Okay, let's, for a lot of us, this thing called Gen AI, ChatGPT, hit us by surprise.
Yeah.
You know, I view myself as a tech person,
Yeah.
but for me, it seemed to
Me
just
too.
jump out. For someone was in
Yeah.
that world, did it seem that abrupt to you, or was it more gradual, more you saw it coming?
I think the reason it had such a profound impact is that it, there's this idea of a capabilities overhang. And so Sam Altman talks a lot about, fast takeoff versus slow takeoff, and this idea that, by incrementally releasing updates that are fairly close to what the frontier is capable of, society will be able to adapt more gradually. I think with the original release of ChatGPT, there was that overhang that caught even experts by surprise. So what you had seen from OpenAI was, with GPT-1 and 2, was this ability to write prose, but there was something about the form factor of a reasonably fast interactive chat experience that was high fidelity and could produce long form content that just nobody had seen anywhere else. And so, there had been, the research teams at Meta had released a few chat experiences where it could pretend to be personas, but it was really like WhatsApp length content, and it was fairly slow to generate. It was like, 20-second latency. And so I remember, so ChatGPT was announced at NeurIPS, the sort of preeminent AI and deep learning conference. And I just remember several nights in a row staying up very, very late. Some of my more recent research expertise is in natural language understanding and machine learning. And it just felt so different from anything that had come before. And I remember, asleep, my wife's asleep next to me in bed, and I'm, it's 1 a.m, and I asked it to generate code that would produce sounds that would, if you had a voice, write code that would produce your voice, and just, it was able to do anything at all. And it just felt so extraordinary. That I think even people who were paying attention were caught by surprise, and it has commanded all of my attention since.
Yeah, it's probably the only thing somewhat analogous to the suddenness of how it popped onto the scene. Probably goes back to when hypertext first happened with HTML, where the internet had a long gestation cycle, but it was when you first were able to start to do these clicks on links that would take you to these different corners of quote unquote the internet before you even really understood and had a conception of what the internet was. And it was like, how could this possibly be? And it just opened up the world to the power and the use of this new thing called the internet.
Yeah.
And it seemed to happen overnight, but then when you study, okay, where did it really come from? No, it happened over 20 years. It's just the accumulation of the things that you needed to make it such that the power of it was so at your fingertips. Well, and that's probably what ChatGPT felt. The dynamic is all of a sudden you can do these things where, I mean, hell, I go back to very early in my career, like my first jobs, and we'd go to kind of conferences and you'd sign up for what you want to attend. And, it seemed like there were a lot of AI topics. And that's, 30 plus years ago. So AI, quote unquote, has been around for a long time, artificial intelligence, but the change in what happened almost overnight, seemingly overnight, was just profound.
Yeah, truly. And it, there are a couple things in what you mentioned that resonate. One is the web, like language models, sort of contains like a sense of vastness. And so you follow a hyperlink and you discover 3 more. And there's this sense that like the extent of it is kind of unknowable. And so there's this desire to continue pulling threads. And, 1994, it's like, what's out there. And language models, likewise, you discover what they're capable of. It's kind of an emergent property, and especially when you think about agentic AI and language models interacting with themselves and critiquing their own work and making decisions based on what I've done so far. And it's, hundreds of thousands of tokens of LLM generated text are now, the context that gives rise to some new behavior. I think there are parallels there, and there's like a product market fit piece too, which is the core inference tech, like the training and inference technology that underlies language models. It wasn't so much a change in how the models were fit, say, so much as how were they post-trained in order to respond to a person. So for a long time you could basically write a prefix, which was like, here's a chat dialogue, and then you prepend it with the person's name and then a colon, and it would generate something that looks like the response to that chat message. Yeah. And it's like, it's not that you couldn't mock this out before, but it was post-training the models specifically to reply without a person having to know that they needed to do that suddenly gave you that like lock-in. And like, I think likewise with hypertext, just, it's not that the content wasn't out there or that you couldn't have, you couldn't access all of that different information. It was just how easy is it to get to.
Which then spurred a whole bunch more content.
Yeah.
Which is kind of what's happening now. And I think a lot of people in the more called casual world who are being exposed to the large language models, they may not realize that that's one form of Gen AI focused on language. But there's whole other forms of AI that still are being developed that are focused not on large language models, but on spatial relationships and manufacturing and interactions with the physical world, and probably a whole bunch of stuff that I'm not even aware of yet.
Yeah.
Can you talk a little bit about other ways that Gen AI are beginning to pop into the scene?
Yeah, so I'll say that language models and natural language understanding is my core area of expertise. I'm not a robotics guy. I'm not even really a vision guy. But one of the things that is so wonderful and profound about the current state of AI is that the same training methods that have allowed us to gradient. Are you familiar with gradient descent, the concept of gradient descent?
No.
So maybe this is a way that I can, in an informed manner, talk about vision and robotics. The basic way that we fit these models is to, so what is a model, right? It's a set of relationships codified in terms of parameters. If you think about, predicting the likelihood that somebody's going to have a heart attack, you might observe two properties of that person, their weight and their blood pressure. And so you tend to see, as weight and blood pressure increase, the likelihood of a heart attack increases. And so you can draw a line. If you have like an XY plot and you have all the people that you've surveyed, you can draw a line separating on this side of the line, you're much likelier to have a heart attack. On this side of the line, you're less likely to have a heart attack. And that line can be defined in terms of a relationship between the X and the Y axis. And so that set of parameters that defines the slope of that line, that is your model. And you can choose any different line, but there's one that best separates those two sets of points. And so the question then is, with these language models that have hundreds of billions of parameters, how do we choose all of those numbers? Mm-hmm. It's like pick any number as long as it's the right one, and it's 400 billion possible configurations. And so what these optimizations,
I like the way you casually say 400 billion
possible combinations. It's crazy. It's like it is like the likelihood of getting it right by chance is zero. And so what gradient descent, which is the class of techniques roughly that underpin all of these different AI models, allows us to do is say, I'm going to start with a random initialization of a set of model weights that define the behavior of the system, and then I'm going to calculate somehow the degree to which that system is wrong. And so, if I make a prediction about the next word in a sentence, say, or I predict among all the possible words, how likely is this one to be the next one, I can then say, well, what was actually the next word? And then I can use, that's called the loss. I can say, what do I predict the arrival time of this flight to actually be? I can use that loss to penalize this current model and then select a slightly better one. And so, in this high dimensional space, you basically, every point has a measure of how bad it is, and we move down the slope of that curve until we get to a parameterization that is not necessarily globally optimal, but is quite good for the purposes of making predictions about what RGB value a pixel in an image will have, or what the next word in a sentence will be, or the location in three-dimensional space of one of the atoms in a protein.
Yeah, and sticking to the word example of the ones you described, the large language models are largely just trying to pick that next word that's most likely to be the right word. And like you said, if it's not in an absolute sense the most optimal word, but relative to the data set you're working with, it's most likely the most optimal. So that means the much bigger data set means it's much more much more likely to be the optimal next word across a much broader set of possibilities, which means if you make an even bigger data set, now the likelihood of you getting closer to the absolute most optimal is even higher. And that's what's, as I understand, that's what's driving, the massive data centers, the massive number of data being processed within those data centers to find kind of that sequence of words that make it sound like there's this intelligence that is speaking to you, producing kind of that narrative that you're asking it to produce, or the outcome you want it to produce. And it's but it's really just what's likely to be the next best word, or a sequence of words. And then what you're pointing out is kind of other ways of using that same technique for spatial.
Yeah, and it's kind of it's a small miracle that the same basic approach has allowed us to solve so many different problems, and so elegantly. And I think, to your point about data center build out, if we take, for example, that heart attack prediction model, if you only sample from 35-year-old males in the Rocky Mountain West, say, the generalizability of that model will be poor if you go and now try to make predictions on a different cohort.
Yeah, in a different part.
Yeah.
Different culture, different part of the world.
Exactly. And so very similarly, if your model has only seen content from Wikipedia, say, or the works
of Fox News,
or the works of Shakespeare, or whatever it is, it will not be, the model will not be penalized if it does not generalize well to unseen domains, or like diverse domains. And so one of the reasons that you see this tremendous need to have more and more data, and then also just train larger and larger models, is that eventually you have something that approaches the totality of every written word that humans have ever created. And now for a model to capture all of the complexity that data set describes, and then be able to make predictions about what is going to come next, you wind up, and it's kind of a compression problem in a way, because you need, basically what these models wind up doing is learning semantic representations like the concept of erosion, or the concept of quantum computing, or left and rightness. And they recombine semantic concepts in order to sort of represent all of the complexity that we experience in the world around us. And so you get a system that has, whether or not it's a real world model, it has higher order understandings of the world. And in that way, 4 billion parameters it's a lot of floats to choose, but it's also like not a large, if you think of it's not a large file. And so somehow we're able to, generate all of this text from like actually fairly few total data points in terms of the model itself. And so it's because it's been exposed to so many different contexts that it's had to learn generalizations.
Yep. And that's where I think we're still discovering, is that the way intelligence works in a more abstract way? Is that the way we as humans are intelligent, just by processing information in a similar way? And I think the clear answer is no. And the reason I say that is because that's not how quantum works. That's not how quantum computing works. Quantum computing isn't, just a different technology that's doing, what you describe, but doing it more quickly or more efficiently. It's fundamentally approaching, I would say, the physical world and the information that might lie within the physical world, and making sense of it differently. It's doing it through qubits and entangled relationships between qubits and other properties, and almost being able to jump into what the answer to a very complex question is, not by the inference that you're describing, but by it just kind of snaps into knowing the answer.
The superposition of all possible model configurations
And it
exist simultaneously, and you don't have to do it sequentially as we do with gradient descent.
Yeah, and it but it could be that it's the combination of those two things is how the natural world really works. It's not one or the other; it's the combination. And I think people are starting to use the word quantum AI to describe where that might be headed. So let's put this aside for a second. We're going to come back to some of these concepts. Let's talk about Brightwave. Let's jump right into Brightwave and what Brightwave is all about. And then we're going to talk about kind of your journey that led to the creation of Brightwave. But let's start with, what is Brightwave?
Yeah, so we build a research platform built for professionals who need to understand the world's most complex problems. And our specialization is really on finance and investment research. And you talk to investors who under very compressed timelines need to understand very complex data sets. You looking at buying a company as a private equity investor, say, and what's being disclosed is this disorderly, massive content that management has produced, and you're one of 3 or 4 teams who are looking at this for the first time ever, and you're making hundreds of millions of dollars, holding the balance, and your ability to triage long tail risk factors to develop a really hardened view on the opportunity that takes into account your firm's unique perspective on the markets and like where opportunities really are. It's a problem historically that teams have just thrown warm bodies at, and you have to read all of this and make sure that no stone is left unturned. And what we're finding at Brightwave is that we're able to help our customers much more comprehensively and thoroughly triage and make sense of these complex data rooms in a way that's very customized and personalized, where you can say, run down this part of a thesis for me, or scan for these 50 long tail risk factors, and we've built this agentic system that's able
to define the word agentic.
Sure.
What does agentic mean? That's word's being used more and more often.
Yeah.
And how would you make sense of that word?
There's kind of the colloquial, like layman's, like what would matter to somebody who just wanted to understand it colloquially, which was it's kind of like the process of an investigative journalist. You discover something, and then based on what you found, you ask follow-up questions, and you repeat that process until you get to kind of brass tacks.
Maybe give a tangible example of that.
Yeah, so you want to understand a solar panel manufacturer and their risks to their growth model, and the agent would issue queries to this information retrieval system that sits on top of this data room, and it would find that the company is expanding its manufacturing capabilities in Vietnam. And so based on that initial discovery, it will then issue follow-up analyses and go look for information about Vietnam. And it might find in a separate document, in an appendix, disclosures that indicate the Vietnam site is under environmental remediation review. And then based on that, it would connect the dots between the growth model requires this expansion of the Vietnam plant. This appendix indicates that that site is under environmental remediation review. And then it would draw an inference, which is that this growth projection may not be realistic given the timeline. The timelines could be impacted for this expansion of the site in Southeast Asia. And so that's an example of how a person would have to do that historically, and would need to be able to keep in mind that finding about the growth model, and then whenever they encounter that appendix, connect the dots and say, oh, that's right, this will impact, and
Plus, you could be chasing a lot of,
and you have dozens of these in parallel, and you're
and maybe two matter a lot, and the rest just are big time sinks to go chase
precisely.
them down.
Precisely.
Yeah.
And so that and what an agent is able to do is perform that work over many, many, many turns and in a massively parallel way. So rather than running down just one theme and doing 2 turns, it's able to spend 20 turns getting to the bottom of 30 different considerations.
And bring to your attention the ones that matter.
Correct. Or like subject those to whatever you articulate as. These are, we believe that GLP-1s are overblown, say. And that's like a thesis we have about the world. And now everything can be read through that lens. And so, but in a technical sense, what an agent is a language model that has access to tools that is operating in a loop subject to some stopping criterion. So at Brightwave, you issue an instruction, and frequently the system will define a research plan, which says, based on this instruction and what I know about the data set, what are the activities, what are the items in my to-do list that need to be accomplished so that I can produce a fulsome answer to this question. And then the model will have access to a set of tools, whether it's image understanding capabilities. I can create Excel files. I can execute code. I can search through the documents. I can pull in content from the web or SEC filings or third-party data sources. And based on the capabilities, these tools I have access to, this model will make a decision about what to do next. Okay, I'll issue this query to the search index over the data room, and content comes back, and then the model inspects that content and then makes a determination about what should I do next. I can exit that loop and say, okay, I'm done. I've gotten a satisfactory answer to this question. Or I can issue another tool call. And an agent is just a language model operating in a loop that has access to tools and some success criteria for exiting that loop. And that is what you see with Claude Code, where it's like I'm trying to build a PR basically, or a Git diff that satisfies some criteria, or I'm trying to pursue this research agenda, or I'm trying to produce a financial model that takes into account this cut of the customer cube. And so that paradigm, which is like a fairly general way to describe the problem at Brightwave, we have been able to solve many, many, many different problems within the finance and investment research space using this technique.
So Brightwave is Series A, Series B company.
Series A, yeah.
So with pretty sophisticated backers, maybe talk a little bit about how were you able to, imagine in Silicon Valley when AI pops into the scene, a couple years ago, the first idea everyone had was, we really should use this thing called Gen AI to help us with our investments. So not a novel thought, probably, that was such a natural place to start if you're with any sophisticated private equity or venture capital firm. How were you able to get traction with that?
Sure.
Why did you have the credibility to get funding, to get momentum, and to build what is a very sophisticated
Yeah.
application of Gen AI.
Yeah, so before Brightwave, I was at Databricks, and I created with my collaborator Matt Hayes the Databricks first.
Yep. And tell us what Databricks is.
Yeah, so Databricks is a data processing platform that is clearly the most successful in the world for helping enterprises understand all of the data that they have access to, and it's one of the breakout scale up companies, and so.
And you joined them where in their history? Did you have a company that was acquired by them? Is that
No,
right?
no. So I was SkipFlag, the company where I was machine learning engineer, was acquired by Workday.
Okay.
And that's actually kind of the connection to Boulder in many senses. But after Workday, where I was director of financials machine learning, went to Databricks, and my sort of philosophy is that
And Databricks was where in its history when you joined?
I think they just raised like a Series L or something like this.
Series
So
L.
I don't remember. It may have been the E or the G. I actually forget. Yeah. But it was like they were fairly along, $32 billion valuation or something, fairly far along in there.
Fairly far along, $32 billion valuation.
Well, it's quite a bit more than that now.
Yes.
So I created their first open source language model, and it was Dolly, and it was the first to demonstrate. It was about 5 months after ChatGPT came out, and as I said, I'd been just like transfixed by like, what is this? How is this possible? And a lot of people were asking themselves like, how did they get it to talk back? And I think there was, especially at that time, a sense that you needed hundreds of millions of dollars and teams of PhDs to build these language models that could react like ChatGPT did. And Meta had released an open source model called Llama that was fairly advanced. It was the most advanced open source model at the time. And
this is, what year are we talking about?
This was 5 months after ChatGPT came out, so it would have been April of 2023.
Okay,
ChatGPT
so only
came out in November, I think.
3 years ago, less than 3 years ago.
Yeah, and it was pretty quickly after the OpenAI release. And so we found that you could train, there was a model called GPT-J that had been out for 2 years, and we were able to get it to write love letters to Edgar Allan Poe and answer customer support tickets. And this, was very, very sort of basic capability, but you could have these issue an instruction and get it to respond. And that took 30 minutes and 30 minutes of compute and about $30 worth of spend on the Databricks platform. And so that was just it was a very, very intense time where a lot of people took notice that like, wow, this you don't have to have access to this proprietary model from Facebook. You don't have to have hundreds of millions of dollars. You could anybody can own and operate language models that behave in this very special way. And so it's funny. I was invited on a podcast called Latent Space, which is a very popular AI podcast, and met my investor Alessio at Decibel Partners, and we just started talking, and had a collaborator and colleague in Brandon Katara, my co-founder and CTO, who I'd worked with at Workday. And he was the former CTO of a CFTC regulated derivatives exchange and clearinghouse. And, his first deep learning patent was filed in 2018. And, we take a technology first approach to this problem set. But I've been thinking about finance and how the structure of the world and how can we actually understand what's going on for a long time. So a couple ways that manifests. After my PhD, I worked at LinkedIn. So you go to linkedin.com, you would see our updates in the homepage newsfeed. But I was also a research liaison for some of the network science work that they were doing. And we published a paper in Nature Communications, so one of the top scientific journals in the world, on how hundreds of millions of job transitions. So if you think of a network of job transitions where a resume defines I worked at this company and then this company and this company. That's a network, and each of those companies has a geographic footprint. So you can see labor flows on the surface of the planet as they evolve in time. And we found that you could predict next quarter S&P 500 market cap changes based on where high talent labor was moving.
Really?
Yeah, and so applicable to economic development in Colorado and a vast number of other could have been a signal at a semi-systematics strategy at a hedge fund, but we shared our finding with the world. And I had also, on a very sort of amateur basis, been interested in algorithmic sports betting. So pricing MMA fights specifically. I like to box and I like to wrestle, and I just think the idea of accurately pricing something is just a very interesting problem. And so from a right to play standpoint, we had two very serious technologists who had some expertise in the information retrieval and natural language understanding space. And we saw in investment research and in finance just such an extraordinary need where you even think in the public markets, just the volume of information that's relevant to an investment decision is astronomical. You at Caruso Ventures, you're just constantly being like, what don't I know here? Mm-hmm. And we saw, as early as, with Auto GPT was kind of, probably June, July of 2023, this idea of, oh, wow, like agents, these systems can like decide what to do next for themselves. And,
that's what's so amazing when you start working with it and, and start iterating and seeing what it can do. It's just mind-boggling. I mean, we had a couple exercises within Caruso Ventures that had to do with major investments that we have or investment decisions we were making, and we began to use it. Yeah. And then push that next layer of use and the next layer of use, and where you end up is like, holy shit! I mean, there's no way we would have ever have replicated this, 2 years ago. Yeah. No matter how much time and effort we put in, we wouldn't have gotten to this thorough of an understanding of what we were doing. Yes. Yet we got there so quickly. Yeah. I mean, it's just bizarre. And I still feel like, we're at the scratching the surface stage, but so advanced now compared to what was going on 2 years ago in terms of the practical understanding of kind of the decisions you're making or even the investments you have and you want to understand them better. It's like, holy shit. Yeah.
Well, and I think like what we've really seen over the evolution of Brightwave as a business is that the core technical insight that we had at the very beginning, which is that these systems will be able to self-supervise and critique their own work and autonomously pursue a research agenda, that as the foundation models have improved, the set of things that they can actually accomplish meaningfully has increased. And so it used to be the case that, if at any juncture you can make 5 decisions, and you're performing a greedy search, it's very quick to get into this kind of nonsense, like where the behavior of the system devolves. And so I think what's happened is that with as the foundation models have gotten more sophisticated, and also as their planning ability and the sort of role of reinforcement learning as a way to sort of allow the systems to make locally suboptimal choices that lead to globally optimal outcomes, much like in game playing like chess. You sacrifice a piece in order to gain material advantage. Things that were not possible for Brightwave a year ago are now suddenly like core capabilities. And so
what is Brightwave? What platform are you developed on?
We use all 3 of the foundation labs. So OpenAI, Anthropic, and Gemini.
And how do you approach it to say, we've got to stay ahead? Yeah. Even just staying ahead of the more generic platforms themselves. I mean, I would imagine that if I was in your seat, I'd be just paranoid that we're at risk of falling behind to the unknown rapid developments that are taking place.
So, you can think of it this way. So when an instruction is issued to Brightwave, under the hood, we issue dozens and sometimes of hundreds of subsequent LLM calls. And so which model is best for which task? It's kind of a portfolio optimization problem. And how do we make sure that all of these decisions that are being made, this agentic reasoning process, that it leads to something that is actually useful as opposed to just wall of text that it's like I'll take it or leave it. That orchestration problem is a core piece of our IP. Like, how do you actually solve that problem in a way that generalizes well to previously unseen tasks? On top of that is a lot of the fit and finish around the product. And so really simple but concrete example of this is in Brightwave, you can click on any finding and it will link you to the underlying document. It will highlight in the document where is this being sourced from. And so product affordances like that, where it's like, just listen, I need to be able to verify all of the facts. It's just much more, if you're building something for 800 million people, the kinds of product decisions that you're going to make are different from if you're building something that is really specifically for people who have to have everything correct every time. Mm-hmm. And so those are two examples of how we think about that problem.
Interesting. It's just fun. I mean, I'm sure you do this, and a lot of people do this as well.
Yeah.
You're just trying to learn, like, what the Gen AI models can do, will do, want to do. Just
where are the edges of its capabilities? Yes. Yeah, I think that is one of the, you contrast it with a database technology. Oracle has a set of documentation, and here's the instructions for how to use this system. And language models, it's very hard to express what are they capable of, and there's this concept of a model card that frequently accompanies releases of new models, and it'll say, here's how likely it is to produce guidance on producing bioweapons, or here are instructions for how to prompt it in order to get high quality output, or this is these are the contours of how it will behave, but it's impossible to enumerate all of the things that it can do. And so that's back to the conversation we had about hypertext, that idea that you are plumbing the depths of something and there's something to be discovered here is much more present with these systems than other types of technology. Mm-hmm. I think that's one of the reasons it's exciting to build in this space.
All right, let's go off on a little bit of a tangent. And you're building an AI company in the early era of building AI companies, like a true, everyone's incorporating AI into whatever they're doing.
But AI native, that's the main thing we do.
What's that like in this era to be a founder?
It's an interesting question.
Of a company that's getting significant funding, significant traction at this early era of building?
I mean, it's exciting, first and foremost. It is very difficult to forecast what will happen, what types of capabilities will become available in 6 months' time. It feels very much like a research process where a lot of our product development is led by the engineering team, in part because what is actually possible is hard to know without trying. And so we will, a concrete example is the Excel agent we just released, which will not only understand Excel files, not at the level of here are all the numbers in this document, but in terms of the formulas and relationships in complex real-world multi-sheet Excel files. And it can produce Excel files that have formulas and relationships and multiple sheets and formatting based on what it's derived from these multi-thousand document data rooms. And that was something that for a long time we thought would be very hard. And it was a very hard problem for a long time. And then...
A long time meaning?
years. I mean, year and a half, say.
Yeah. The
Yeah,
time
sure. Yeah,
horizons are so compressed.
it's also very
like
compressed.
A year ago, it seemed like it was
Forever
and
ago,
it was
yeah.
a really long time. It took 9 months.
Yeah, precisely.
So it's actually building kind of complex
Yeah,
spreadsheets.
correct. Yeah, not at the level of producing an entire financial model, but directionally, it, we didn't understand that it would work as well as it had, and we have one system, this kind of core technology that we've built, which is this agentic orchestration system and all of the attendant tools and capabilities that is able to solve many, many different problems. And so we took a crack at this Excel. It's finance professionals live and breathe Excel, and so it's a fairly core capability for a system like ours. And we found that it was able to produce this kind of output, these structured outputs in the form of high quality Excel files, and that happens again and again and again, where it's we're not sure if something is possible. We treat it like a research problem, an applied research problem, and then discover based on what we're actually able to produce whether or not there's something here. And so it's very much like an exploration of what's possible.
How are you able to get the right talent to work for Brightwave?
Yeah, I mean, so there are a couple things. We have we're so lucky to work with incredible people.
And incredible people want to work with incredible people. That's
yeah, true. And I think so. A couple things. One is that our, we've just been very, very selective about who we work with. So it's a small team. It's 10 people, and we have been able to do that in part because we've hired generally more experienced professionals. And have been supported by the upswing in AI software engineering tool capabilities. And so you have experienced professionals who know what needs to be done on the engineering side of the house, working with tools that allow them to accomplish, 10,000 lines of code in a day. And on our commercial team, we our head of go-to-market, one of the top sales professionals at Looker, through its acquisition by Google for $2 billion and some dollars. And so, he just he's a compelling and charismatic person that, you want to be around. And so I think just being very, very selective about the skills and experience intersects with trying to hire for people who are intrinsically motivated to do great work. And so, one of the things that I frequently ask very early in the interview process is, I say something to the effect of, do you, I've kind of got your biography here. I say, LinkedIn profile pulled up. I know, the contours of where you've worked. Do you mind if I start with a pretty open-ended question? And they say, yeah. So, well, what are you trying to do with your life? And just, it's incredible to see where people go with that question. And I think it's always an interesting conversation. And we are selecting for people who, I think the desire to achieve greatness is installed by your parents and your coaches and your teachers, and that it's very, it's like harder to change that. That can be changed, but more on like the 5 and 10 year time scale for a person. And that
is it instilled by others, or is it more innate?
I think it is a values. I think it's values. Certainly there's some innate, like.
Because I haven't thought about as much as you have, perhaps, but I would think it's 80% innate and 20% influence.
So think about like, I don't claim to have the final answer. This is something I've thought a lot about. I think ambitiousness is fundamentally like an anxious trait, which is like, I'm not satisfied with how things are now. There's something wrong with how things are right now that needs to change. Mm-hmm. And so I'm going to go to all this trouble to start a company, to build, create a technology. It's and so is there, how much of that is, like something needs to change is like a product of your environment versus like purely genetically innate, like unclear. What I will say is that what we call an ownership mindset, I think that is a learned behavior. And so, like, have you ever read the book Man's Search for Meaning by Viktor Frankl?
No.
So he's a Holocaust survivor, psychoanalyst in the 60s, wrote this book about his experience in the concentration camps and why some people were able to endure where others were not. And his kind of central finding is that the people who were likeliest to survive were those that recognized the inalienable ability to choose how you respond to your environment and circumstances. And it's like, they can take everything from me except the dignity of choosing how I react. And that idea of, I can't control the market.
Is that stoic? Is that
There's like, elements of stoicism in there.
Yeah.
But the markets may tank, your competitors may, get way out front unexpectedly. This team that you work with may let you down. You can't control traffic, but you can plan to leave early. And that ability to there's something really, really powerful about recognizing that like I'm always in the driver's seat, even in circumstances that suck. Like I am always choosing how to respond to my environment. And I think that is a learned behavior. And so that idea of like, what are you trying to do with your life? It's really about, do you have a plan and are you actively participating in doing something? It can be anything. But it's like, frequently it's like, is this the first time you've thought about this question? It's what I'm trying to assess. And so you hire people who have demonstrated greatness in the past, who have been, participants and party to great things, and then sort of try to be fairly inerring about hiring people who have the right mindset. And we've been able to accomplish a lot with a small team because of that.
And where is how much your team is here in the Boulder area versus
probably 30%. We have an office in New York as well. It's a larger market. It's where a lot of our our commercial team is in New York. It's where a lot of our customers are. Yeah.
And tell us about the AI scene in Boulder and in Colorado. I know there's the AI builders that used to be Boulder AI builders, but it seems like it's more Colorado.
Yeah, it's gotten bigger and bigger. Yeah.
So tell us about the AI scene here.
I would say. I mean, it is punches surprisingly above its weight class. Like we share an office with the free play guys who run the AI builders meetup, but also like Zed, which is Series B, Redpoint funded, code editor, and the head of GPU scaling for the GPT-4 train lives in Boulder. And
oh, really?
Yeah, fella in town, Anthropic's new head of cybersecurity products, lives in Boulder, like in Colorado. I think he lives up the hill. But I think that what is so special about Colorado is that you have, and Boulder in particular, it's like there are probably 80 cities in the U.S. that really matter. And that number is smaller, and I don't mean it quite like matter in the sense of like the dignity of the people that live there, but it's like, it's not a long list
in terms of AI. In terms of AI?
Just generally. Like there are probably 80 cities in the U.S. that have more than 100,000 people population. It might be 120, but it's not 500. Mm-hmm. And it's easy to like forget that it's not a long list of cities in the U.S. And when you think about the properties of Boulder in particular, where it's a mountain town with a university, but also has Google and Microsoft and Amazon and formerly Uber, and the Twitter HQ was here for a long time, and Techstars. It's just like a very, very unusual confluence of infrastructure and talent in a place that is really, really extraordinary. Similar in many respects to the Bay Area in that regard, not in terms of scale, but like talented people in a place that has naturally beautiful appeal. And so, with the AI scene, I think you've gotten a lot of people who have chosen to make this their home, who are exceptional people, and are drawn here or from here because of it. It's such an extraordinary place.
And you see that momentum growing?
Well, I think to your point about policy, it's like you have to continue to have policies that, support reasonable legislation about like the responsible use of AI, like to the extent that there is, at the state level.
Has the AI bill in practical, has that?
It is not it has not negatively impacted our work or progress, but it, I think again the conversation.
To me, it's more of a signal.
Yeah.
At first, it seemed like it might be a practical,
Yeah.
A very real inhibitor, and maybe people have looked past that, like this isn't sustainable. That Colorado's going to have a very anti-AI development environment, and other areas are going to have positive ones. Those are going to kind of get to the same
It's a
spot.
market.
But the signal it sends is what I worry about. The signal of the political leadership of instead of saying we're going to do all we can within reason to want to make this as great a place as possible to attract innovative people, which includes investors, includes entrepreneurs, includes creative types. We value that. We think that's a big part of our community. What can we do to make this more appealing? Instead of doing that, they're burning a bunch of cycles trying to figure out how to overregulate an area that's the next revolution in how people are going to live and work.
I mean, it's like fundamentally, is the signal you want to send that we see AI as an opportunity or as a problem to be managed? And the real answer is that it's complex and requires like nuanced judgments. But, if somebody's thinking about starting a business here or relocating here to do that, certainly, am I going to be seen as friend? Is what I'm doing going to be seen as friend or foe? Is like near the top of the list for like, should I make the effort?
Mm-hmm.
Yeah,
for certain. So now let's look forward in time.
Sure.
Put on your complexity hat, your AI looking forward hat. Where do you think we're headed? I mean, what do you think is happening? Because this feels like a moment that is beyond where is AI headed, but it's almost like we're rediscovering fundamentally how the world might really work, and how intelligence, how environment, what's really going on in and around us. Maybe even there's even thoughts that there's aspects of what we might have thought of as settled science that maybe there's a lot yet to be discovered, and that we might be on the cusp of discovering kind of that next level of underlying science itself and the meaning of things. Let your mind wander a little bit and tell us, when you step back and say, where are we really going?
Yeah.
Where do you think?
So I see a lot of it's complicated. Like I would say there's a tremendous amount of opportunity. There are also some really like pragmatic, it's not a policy thing. It's more just like societally, like what do we want to accept and prefer? Most problems that can be well specified, I think, will fall to this class of techniques. And so what I mean by well specified is, can you define that loss function? Like how bad is a model at predicting what will happen? And so I think like drug discovery, robotics is a good example. Is it able to accomplish the task? I think we're going to see an extraordinary uplift and continuing uplift in the number of different types of problems that are solvable by AI systems. I think that will intersect some limits in our ability to perceive what better is. So like the chat use case, we may have saturated like chat as like how much better is GPT-6 going to be at responding to the majority of the questions that people ask of AI. Many of these things that people ask a language model for in chat context like are already fairly well addressed by the current technologies. Now, you're going to see more more sort of use cases around AI taking actions on my behalf, where again it's this set of tools within a loop, and that could be like travel planning, or manage my finances, or I want to help me schedule this meeting. These are kind of like the things that we know to ask for, but like a lot of the things that we try to do like on a day-to-day basis are already within the capability set of the current models. It's more of like a product overhang, like the businesses that solve those problems really well and with like product affordances that you like are being created now. And so I think part of the task ahead of us is like, how do we ask the right question? It's like Hitchhiker's Guide to the Galaxy. You've got this machine that has the answer. You need to know what the question is. How do we ask the right questions?
Well, what people's lives are going to be better because of, or I said, and what type of people's lives might not be better?
Well, so rather than talking about the types of people, maybe it's the types of
Categories,
problems, and it's like who has those problems. So I think like medical advice is a place where life is going to be a lot better for many people. I mean, for $20 a month, you have a world-class doctor in your pocket. Like that's, you have my son had a sore in his mouth. We were able to take a picture of it, and it was like, here's, how should we approach it? Oh, saltwater gargle. Great, thank you. But even with more, complex disease processes, the ability to get access to like, from a nutrition standpoint, what is the optimal mix of foods in order, evidence-based mix of foods in order to support healthy outcomes for this disease process. It's like, that would be a $1,200 visit to a nutritionist at the Mayo Clinic. You can just ask and get like a totally personalized health plan, or like, these are the drug-drug interactions that, here's the current loadout of prescriptions I'm taking. What are some interactions that I need to be aware of? That stuff is just like going to be transformative.
All your blood test results to it, and
all of that
detail, and tell me what I should do.
All of that. So I think that's going to be extraordinary. I think there's certainly going to be my concern that like people are not going to be able to find a way to be productive is somewhat low, just because every other major technological disruption has seen humans adapt. And I think a lot of the things that we consider, like a lot of the work that people presently do, is not especially ennobling, or it's like it's the only alternative has been to have a person do it. And the idea that this person who is doing rote data entry over invoices, say, will not within their current organization find a way to be useful, that seems like job displacement will happen. I have a lot of faith in humans' ability to adapt. I think the stuff that would be more concerning to me are the social effects. So if you think about like social media feeds, we've seen how that has led to more isolated behaviors. Like I'm less likely I can get all of my information that I need ostensibly from the web, so I'm less likely to just interact at random with some stranger, because the likelihood that they'll have information I need is lower. So the incentive for me to be gregarious has decreased. I think that it's easy for me to see people having romantic relationships, or even just like social relationships with AI systems, in a way that continues to corrode some of the social fabric that like we need to hold us together in uncertain times. And that you've got large swaths of the population who are single and aging and don't really see any prospects for themselves socially, and have kind of withdrawn. Like I think that right now is a pretty uncomfortable way to be. But if you can just draw up kind of an unlimited number of AI friends, I don't see like the incentive to solve the problem really goes away, and just witness that humans occupy and enjoy long distance relationships with other humans. Like we have the ability to pretend for a long time. And I think that that may be, 15 years' time when we look back at like how did this affect society, I think like the further corrosion of our social fabric may be one of the negative effects of AI.
Yeah, and I think we all have to have a self-awareness of that and figure out how to do everything we can to offset that, create opportunities for people to interact in person, in real life, in the real world. Truly. Get them away from their screens.
The stuff Endeavor does with the dinners, it's just like you have to, or AI builders meetup, you have to make the effort.
Exactly, and getting those who are maybe more reluctant to take advantage of that stuff to figure out how to prompt them to do so, because they can get themselves into some pretty deep places. Yep. So anything that we haven't covered, I mean, we could go on for another hour and a half.
It's been a very fulsome discussion.
Anything else that you would like to share that we haven't already hit?
I think, the highlights have definitely been touched on. I've really enjoyed the conversation.
Well, I'm excited with what you're doing with Brightwave. I'm excited in general to see the AI activity around here.
Yep.
Obviously, I care deeply around kind of the environment around Boulder, around Colorado, and having us be able to play a meaningful role in AI is so important, and people like you doing it here is a big deal. So thank you.
It's an exciting time. Thanks for having me.
Absolutely. All right. Well, thank you.
Thank you for listening to this episode of The Bear Roars. Check out Stretch, the new song from Dan Caruso, with music by Jason Mendelson, available now on all streaming services. If you enjoyed the episode, please like and subscribe on your listening platform. This podcast was produced by Loud Bear Productions and edited by Kendall Weinberg with support from Gibson Siegert.